Okay, so today we're going to go through, finish up these notes on hyperbolas. So I'm going to go through the slides and get to the point where we left off. So today what we're going to do is talking about how to find the equation of a hyperbola. These are the steps that you need to take. First thing you're going to do is use the information that's given to determine if your hyperbola is vertical or horizontal. If it's vertical, it's transversing the y-axis. If it's horizontal, it's transversing the x-axis. After we figure out which one or which variable is going to go first based on if it's vertical or horizontal, next we'll find the center. Then we're going to find the values of a and b. And then remember, sometimes we need to use the formula c squared equals a squared plus b squared to find usually to find b squared. Some vocabulary here. Again, when you see the words transverse axis, this means the axis that it's crossing or touching. So if it gives you the length of the transverse axis, you set that number equal to 2a. If it gives you the length of the conjugate axis, you set that equal to 2b. These are vocabulary words that tend to be specific to WebAssign and to our textbook. So just be aware of these vocabulary words. If you get any WebAssign questions where they're giving you the length of the transverse axis, just remember to set it equal to 2a, solve for a. So let's try our examples. So again, I'm going to give myself a little rough sketch just so I can see which axis it is, or if it's vertical or horizontal. Again, if you remember from yesterday, when the center is at 0, 0, the focus points, this would be a negative c, comma 0, c, comma 0. The vertices are negative a, 0, and a, 0. This is for a center at 0, 0. And we're going to confirm that the center is at 0, 0 by giving ourselves the little visual. So I have a focus here at negative 3, 0, and 1, 2, 3, positive 3, 0. And then I have vertices at negative 2, 0, and positive 2, 0. So you can see that your hyperbola is going to transverse the x-axis. So this tells me the equation I'm going to be using is x squared over a squared minus y squared over b squared. This is what I'm going to be filling in. I can already find my c value because that's how many spaces away that c is from the center, and again it's right here. My center is the midpoint between the two vertices, and it's or the midpoint between the two foci. So it's the center right here is at 0, 0 like I thought. So my c value, you can see that the focus is 3 spaces away. And the vertices, it's 2 spaces away, and that's your a value. So a squared, so a equals plus and minus 2. So a squared equals 4. C equals plus and minus 3. So c squared equals 9. This is what I got from my given. But remember, what we're filling in the formula is just a squared and b squared. So to get b squared, I use the formula c squared equals a squared plus b squared. I'm going to fill in c squared with a 9, a squared with a 4. I'm going to isolate b squared by subtracting 4, and b squared equals 5. I do not need to square root it because that's all I'm looking to fill in is b squared. So let me go ahead and fill in x squared. A squared is always the denominator of the first fraction. Y squared over 5 equals 1. And you're done. This time they're giving me the vertices and an asymptote. So again, let's go ahead and give ourselves a little visual. Again, it's touching the x-axis. I have one here at -1 and one at +1. So again, this is my negative A0, A0, because the midpoint or the center point here, the midpoint of the vertices is at 0, 0. So my center is at 0, 0. The distance between the center and each of the vertices is my A value, and it's 1, or plus and minus 1. So A squared equals 1. You need to memorize that when your hyperbola transverses the x-axis, the formula for the asymptote was plus and minus b over ax. So these numbers that are here in front of x, that's what b over a is. So I'm going to do b over a is equal to 4 over 1. I can make that -4, +4 into, make it a fraction by putting 1 in the denominator. Now, normally what I'm going to, well, let me go ahead and solve this as a proportion. Now, already you can see that a equaled 1 here, so a squared is 1, but let's just go ahead and solve and substitute. So I'm going to treat this as a proportion, b times 1, 4 times a, so b equals 4 times a, and I already know that a equals 1, so I can plug that in there, so b equals 4. So b squared equals 16. So that's what I'm filling in, b squared and a squared. Remember, it was touching the x-axis, so it was the same formula as before. Remember, a squared is always the denominator of the first fraction, and the top of that first fraction is the axis it's touching. So let me fill in x squared over 1, y squared over 16, and it equals 1. Now, on a standardized test or a multiple choice test, they're actually going to simplify this equation and take away the 1 in the denominator and just leave it as y squared over 16 equals 1. Be aware that these are both equivalent equations. I will be okay on the quiz on Friday if you leave the 1 in the first denominator. However, be aware on an SAT or a PSAT, they will probably not include the 1 in the denominator. Pretty good? Let's try the next example. Again, still an asymptote and a focus point this time. So again, let me give myself a little visual. This time, the foci are located on the y-axis. Remember, the focus and the vertices are always on the same, they're going to transverse the same axis. So because these are on the y-axis, I know the equation I'm using is y squared over a squared, x squared over b squared equals 1. Now remember, for the focus, that distance from the center, again, this center of 0, 0 is the midpoint between these 2 points. So I can see that my C value is going to be 5 because they're both 5 spaces away. So C squared equals 25. Now, when your graph touches the x-axis, the y-axis, the asymptote formula that you memorize is going to be A over B. Everybody good there? Okay, so now this 3/4 is really the A over the B. So A over B equals 3/4. Good? Now, you may think, well, why can't I just square 3 and square 4 and then put those in the denominators? Sometimes that's what it's going to be, and in this case it will be that. But what if A over B was actually a simplified fraction? What if it started out as 6/8 and then it reduced to 3/4? Then you would get the wrong A squared B squared. So this is why it's important that we actually solve this as a proportion. So I'm going to go ahead and cross multiply, and I'm going to multiply 3 times B and A times 4, and I would get 3B equals 4A, divide by 3, and B equals 4/3A. Now, I'm going to be plugging this information into C squared equals A squared plus B squared. Yes?
Could you also switch it and like make 4A equals 3B and solve for A and plug it in?
Yes. Yep. You could have done it either way. Absolutely. All right. So now let me go ahead and replace C squared with 25, because that's what I found up here. I don't know anything about A because I solved my equation for B. I'm going to take 4/3 A, put it in here, and then I have to square that. So now I get 25 equals A squared plus 16/9 A squared. I'm squaring the 4/3, and I'm also squaring the A. I need to add these like terms. This is a 1A. I'm actually going to change it to a 9/9, so I have a common denominator, because I know 1 equals 9/9. So 25 equals 9 plus 16 is 25/9, A squared. I need to isolate A squared, so I'm going to multiply by, I'm dividing by 25/9, which is really multiplied by the reciprocal. That'll cancel. 9 equals A squared. Going to use this formula one more time to get B squared. Plug in 25 for C squared, 9 for A squared, subtract 9, and B squared equals 16. So now that I have A squared and B squared, all I have to do is plug it back in. Everybody good? So let's go back. So y squared over 9 minus x squared over 16 equals 1. And you're done. Again, some of these are a little bit more work. For example, the next one is a little bit more work because they're giving us an ordered pair. Everybody good on this one? Let's try the next one. Again, let's give ourselves a visual. Again, these are on the y-axis, 0, 2, 0, -2. This ordered pair is going to be our x and our y. So because it's touching the x-axis, the y-axis, and again, the midpoint between these two vertices is 0, 0. So I still have a center at the origin. So I can still just use this formula. I don't need to worry about h and k. I do have an a value. I can see that this vertice is 2 spaces away. So a equals 2. So a squared equals 4. I don't have enough information to use c squared equals a squared plus b squared. I only have a squared. So now what I'm going to do instead is use this equation and plug in the x and the y in the numerators. So I'm going to be doing 5 squared over 2 squared minus negative 2 squared over y squared. Let me evaluate all these exponents. 25 over 4 minus 4 over y squared equals 1. Oh, there should be a b squared. Sorry. I'm sorry?
Yeah, no, I was just saying that it should be.
Yeah, sorry. Yep. There's a b squared. Okay. I need to get b squared all by itself. So I'm going to change my whole number 1 into 4 over 4. Because what I need to do here is move the 25 over 4 to the other side. Negative 4 over b squared equals negative 21 over 4. Again, I'm going to solve this as a proportion. So I'm going to multiply this times this. I end up with negative 21b squared equals negative 16. Divide by negative 21, and b squared equals 16 over 21. Now I have enough information because all I needed to fill in was a squared and b squared. And my a squared I found from the original given information. So it's going to be y squared over 4 minus x squared over 16 over 21. Now, this looks bad. You really shouldn't leave a fraction in a fraction. However, some standardized tests leave it like this. However, others are actually going to divide this second fraction here and do a key flip change and basically just move the 21 to the top. So you'll also see the answer written as negative 21x squared over 16 equals 1. Be able to recognize that both of these are good answers. Depending on the test you're taking, one may leave it with the fraction in the fraction, and others will divide it and move the 21 to the top. Now, I know this is the end of the notes, but I'm actually going to add 5 more examples just to make sure, just to give you variety here. All right, so let's go ahead and keep going here. Add a page. This time, I'm going to give it to you as an x-intercept, negative 3, 0, 3, 0, and then I'll give you the foci, negative 5, 0, and 5, 0. Now, if you can already see that they've got zeros in the order pairs and that all the numbers are in the x spot, you don't necessarily have to give yourself a visual. Again, we can see that the midpoint is going to be the 0, 0. So the equation I'm using is x squared over a squared minus y squared over b squared equals 1. Again, if the little graph helps you, you can quick do a rough sketch here. And then put your focus points here at negative 5, positive 5. Your x-intercepts are actually your vertices because the center is here at 0, 0. So we've got the center here at 0, 0. This x-intercept is a vertice, and these are focus. So I can get my A value. You can see that it's 3 spaces away. And my C value is going to be 5. So A squared equals 9 and C squared equals 25. So now I'm going to use the formula. C squared equals A squared plus B squared, because that's what I'm filling in. I already have A squared, but I need to find B squared, and I'm going to use the formula. 25 equals 9 plus B squared. Subtract 9. 16 equals B squared. And that's what I need to fill in. So final answer, x squared over 9 minus y squared over 16 equals 1. Now we'll do it as you're going to be given a y-intercept. Let's see. Somebody sent me a message in the chat. Let me see if I can see this. All right, somebody asked me if the quiz is multiple choice. No, it is not. Again, the quiz is all free response. You're doing it on an answer sheet. You need to print out the answer sheet. I will be posting it on Canvas. If you do not have access to a printer, you're going to format your piece of paper like the answer sheet that I'm going to post. All right, so here we go. Keep going. I'm going to add another question. Number 10. Y-intercept. 0, negative 9, 0, positive 9. Foci. 0, negative 15, 0, positive 15. Again, if it helps to give yourself a visual, you can see that they're all on the y-axis. This is the focus. This actually, y-intercept actually is the vertex. Or a vertice. And then again, the focus. So again, you can see that the midpoint between these two is 0, 0, and same here. So again, my center is still at the origin. It's touching or transversing the y-axis. So the equation I'm going to be filling in is y squared over a squared, x squared over b squared equals 1. I can already get my a value. It's the distance between the vertice and the center. So a equals 9. And my c value is center to focus, and that's going to be 15. So again, I need b squared, so I have to use the formula again. C squared equals a squared plus b squared. C squared again is 15, or c is 15, a is 9. I'm going to square them. 225, 81. Subtract the 81. 144 equals b squared. I now have everything that I need. B squared is 144. A squared is the 81. So let's fill it in. Y squared over 81 minus x squared over 144. And it's set equal to 1. And you're done. Yes?
Are the vertices always the intercepts?
you're gonna have to look to see what they've given you. Chances are they probably will be. Everybody good? All right, now we're gonna go back and do an asymptote and a vertex. This is where it's critical because the asymptote is a simplified fraction. So it's critical that you solve it as a proportion. So number 11, vertices located at -10, 0, +10, 0. And I have an asymptote at y equals plus and minus 5x. So again, if you give yourself the visual, -10, 0, +10, 0. You can see that the center is 0, 0. We can figure out the a value. A is 10 spaces away from the center. So a squared equals 100. You're going to memorize that when your hyperbola transverses the x-axis, the asymptote equation is y equals plus and minus b over a. So when it touches x-axis or it's horizontal, the asymptote is b over a. So again, if I take that 5 and I make it a fraction and make it 5 over 1, set it equal to b over a. And now if I go ahead and cross multiply and multiply b times 1, 5 times a, b equals 5a. I already know what a equals. It equals 10, so I can plug it in here. So b equals 5 times 10, so b equals 50. So b squared equals 2,500. So now I can just plug it in. So y squared over a squared, which is 100, x squared over 2,500. So if you just would have taken this 5 and this 1 and squared it, you would get the wrong b squared and a squared. Because 5 over 1 was a simplified fraction. It was 50 over 10, and it reduced to 5 over 1. So this is why it's important to do it as a proportion, because it could be a simplified fraction.
Mrs. Corey,
Yes.
why do you have the y squared first? I thought that the one that we would put first is the x.
Oh.
The x shows up as different in the vertices.
You are correct. Thank you. All right. Good catch. So this is going to be x squared first and y squared because it's touching the x-axis. Very good. Thank you, Simone. All right. Everybody good on that? Good catch. So always the variable you see first is the axis it's touching. All right, let's keep going here. Do a couple more. Number 12. I'm giving you vertices again. So 0, -5, 0, +5, and I'm going to give you a point that it passes through. So it's passing through the order pair 3, 10. So again, remember when it passes through a point, this is x, this is y. Again, you can see if it's vertical or horizontal. You can see that it's going to be touching or crossing the y-axis. So the formula I'm going to be filling in is going to be y squared over a squared, x squared over b squared equals 1. All I know is my a value, and a equals 5. So a squared is 25. I don't know anything about c squared or b squared, So I'm going to have to do the longer formula where I plug the order pair in for x and y. So I'm going to be doing 10 squared over 5 squared minus 3 squared over b squared. 10 squared is 100. 5 squared is 25. 3 squared is 9. Now, if any of your fractions can actually be simplified to an integer, I would do that. 100 divided by 25 is 4. I'm going to move the 4 to the other side. Negative 9 over b squared equals negative 3. Now, I can either choose to add a 1 to the negative 3's denominator and do it as a proportion, or I can say, you know what, I'm just going to multiply both sides by b squared to get it out of the bottom of the fraction and end up with negative 9 equals negative 3b squared divided by negative 3, and b squared equals positive 3. So now I had my a squared from the beginning, and now I just calculated the b squared. So a squared is 25. So let's fill it in. So final answer here is y squared over 25 minus x squared over 3. Let me try to squeeze in 2 more examples before the bell. Here we go. This time, foci located at negative 3 radical 5, comma 0, positive 3 radical 5, comma 0, with an asymptote at y equals plus and minus 2x. So again, if this is your foci, and again, it doesn't really matter. You can just see that it's on the x-axis. So you can see that it's equidistant here. So the c value is going to be 3 radical 5. So let's square it now. So if I take c equals 3 square root 5, square this side, square this side. The square goes to the 3 and to the radical. C squared equals 45. When your graph transverses the x-axis, you're memorizing that the asymptote is b over a. So here, what I need to do is fill in so I can set b over a equal to 2 over 1. I'm going to cross multiply and get b equals 2a. And now I'm going to plug it in to the formula. Now you could have also solved for a, either way, but I'm going to do c squared equals a squared plus b squared. 45 equals a squared plus 2a squared. A squared equals 4a, or a squared plus 4a squared. Add these like terms. Divide by 5. And a squared equals 9. I now need to plug it back into this formula one more time. 45, got that from there. And then the a squared, I just figured out. Move the 9. 36 equals b squared. So again, the asymptote of 2 over 1 was a simplified fraction. So again, my final answer here, x squared over 9 minus y squared over 36 equals 1. One last example, and this one's actually going to be an example where the center is not at 0, 0, because you will have this in the web assign. So your given is a vertice at 5, -2 and 1, -2, and also an asymptote. Y equals -2 plus 3 over 2, x minus 3. Remember, this is k as it is, but this is backwards for the h because it's in a parentheses. So let's graph the vertices, see if it's horizontal or vertical. 1, 2, 3, 4, 5, 1, 2, and then 1, -2. So you can see it's horizontal. So the equation I'm going to be filling in, okay, so when you see that your hyperbola is going to be horizontal, remember this right here, this plus minus, is going to be b over a. So I'm going to go ahead and set b over a equal to 3 over 2. I can cross multiply, and I can get 2b equals 3a. And then I can divide, and b equals 3 over 2a. Now, I can also figure out, since these are the vertices, I can also realize that my center is not at the origin. I can find the midpoint to figure out the coordinates for the center. 5 plus 1 divide by 2, -2 minus 2 divide by 2, 6 over 2, -4 over 2. So 3, -2 is going to be my center point. So it's going to be right here. So I can calculate my A value, and you can see that this vertice is 2 spaces away, so I can get A equals 2. I'm going to take that A equals 2 and plug it in here. So 3 over 2 times 2 gives me B equals 3. So B squared equals 9. I can just take my A equals 2, square it, and A squared equals 4. So now I have enough to fill in my equation because my center is my HK. So I'll be adding this, this, and this to my equation. So let's go ahead and fill it in. Final answer here is x minus 3 squared over 4 minus y plus 2 squared over 9 equals 1. Final answer. So this was the single example here where the center was not at the origin. So that's it for the writing the equations of the hyperbola.